When we're finding the total surface area of a cylinder, there's a couple of things that we need to know. We're going to need to know what's the radius of the cylinder, and we need to know what the height of the cylinder is. Okay? So let's first understand what is the total surface area. The total surface area is going to be the bases, and those are your circles on the cylinder, and then it's going to be this area around the outside, which is, if this were a soup can, the label around the soup can covers the lateral surface area. Okay, so we need this plus, I probably shouldn't put an X, this plus this plus this, so everything that you see on the outside of this can. Okay, so what does that mean then? How does that help us to figure out what the formula is going to be? Well, you may remember the area of a circle is pi r squared. Okay, and we've got two circles, so we're going to have 2 times pi r squared as part of our equation, and that's right here. And we're also going to have, for this area here, if I were to take, let's pretend this is an oatmeal, one of those cardboard oatmeal cylinders, and if I were to cut it up the side and open it up, I've actually done that before. It's going to end up, if you lay it flat, it's going to end up being a rectangle. Okay, if you cut it, relatively straight. And then you're going to have the tops that are connected to the sides of this rectangle. Okay, now we've already figured out that this is going to be pi r squared, and this is pi r squared, so we're going to have 2 of those. But how do we figure out what this space is in here, our lateral surface area? If you were to take this long piece here, this rectangle, and you were to fold it back up into the circle that it used to be, that's a little too light, isn't it? And fold it back up into the circle, you would notice that this length is the same as the circumference of the circle. Okay? So, and if you remember, the circumference of a circle is 2 pi r. Okay? So, and when you solve for the area of a rectangle, it's just length times width, right? So now we have one thing. We have, all we need to know here is the radius. So we've got one part of our equation. And now all we need to know is, what is this right here? What is that length? Well, that is the height. It is between our 2 bases. And the height is always between, when you have 2 bases, it's between the bases. So this is the height right here. Okay? So now, once we have the height and we have the radius, we can solve this whole thing. And you can see this is like length times width, 2 pi r times h. And that's the second part of this equation. And you just add those together and you get your total surface area. So let's go ahead and do that. Let me erase all of this if I can. I'm not going to do it in one step. Okay, still not there. It likes to erase in layers. Okay, so now we can go ahead and label this soup can. So we're going to do a height of 5 centimeters. So I'll put h there. Height equals 5 centimeters. And then for the radius, we're going to do radius is equal to 3 centimeters. Okay. All right, now we can go ahead and plug these values in. Just a side note too, this equation here is really the same as this. It's just 2 pi r is in both parts of this equation. So we can kind of make it a little more succinct, a little bit smaller footprint, I guess, of an equation. This one doesn't help me to remember how to do it though. But whatever you see is the right way to do it. Okay, so let's go ahead and solve our equation. So we've got, the surface area total, and this is just my notation, adding the t, just so I know what I'm working with. So this is going to be 2 times pi, r is 3, so that's going to be 3 squared, plus 2 times pi, again, r is 3, and the height is 5. So now we have 2 times pi, I'm just going to do kind of one step at a time here. 3 squared is 9, plus 2 pi, and 3 times 5 is 15. Now, 2 times 9 is equal to 18, and we'll just keep the pi there, plus 2 times 15 is 30 pi. And it also may be helpful for you to know, don't solve for pi until the very end of the problem. Otherwise, you got a lot that you're having to deal with that is unnecessary. Okay, so 30 plus 18 is 48, so that's going to be 48 pi. Now, and that's going to be in centimeters squared because we're talking about area, okay? So the total surface area is 48 pi centimeters squared. Now, if your teacher asks you to leave it in terms of pi, this is what they mean. It means leave that pi just like it is and don't do anything else. Now, your teacher will probably say, substitute pi for either 3 or 3.14, or even do it on the calculator to get the most accurate information. So let's go ahead and multiply 48 times 3.14, and let's see what we get. Let's see, 4 times 8 is 32, 8, 9, 10, 11, 3 times 8 is 24, and 1 is 25. Placeholder, 16, 4 times 1 is 4, plus 1 is 5, and 3 times 4 is 12. Now let's add all this together. 10, 5, 1. Does this make sense? 48 is about 50. 3 times 50 is 150, so yes, that makes sense. Let's go ahead and deal with this decimal so we don't forget. So we end up with 150.72 centimeters squared. And that is your answer. All right, I hope this helps. There's a couple other videos on cylinders where we find the lateral surface area and we also find the volume. I hope this helps, and I will see you in the next one.